Hello, in this video I'm going to explain to you how you can program sonic sensor to build a robotic vacuum or robotic car. I'm going to give a little demo of a small interesting project which I built using a sonic distance sensor. This sensor is being used in robotic arms and robotic car to measure the distance between itself and object in front of it, right? So what you see on the screen here, which I'm pointing out with my pen, is the distance between this sensor and an object in front of it. Right now I put an object there, a white paper, as you can see. So distance between this sensor and that paper is now, you see, 69, 70. It's going to keep fluctuating between 69, 70 and 71. Why? Because the accuracy is 0.3 centimeters. It's going to fluctuate between that. So I'll explain later on how it measures the distance, and I'll explain all the hardware, but let me give you a little demo. I programmed this one to measure the distance between, let's say, whatever the object I put in front of it. So right now I'm putting my hand in front of it, right? You see? So you see now the distance is 30 between this sensor and my hand, right? So as you see on the back screen here, it's showing the distance between my hand and the sensor. And I programmed this in such a way that when my distance between my hand or any object, distance between this device and any object is less than 30, between 30 and 20, right, the green light should be turned on. So I'm going to move my hand forward and bring the distance to 30 or less. It's going to turn the green light on. Right, here you go. See, 25, 26, now green light is on. But when I'm going to move further my hand towards the sensor, it's going to result in decreasing the distance between itself and my hand. So when the distance goes between 10 and 20, less than 20, then what's going to happen is it's going to turn the blue light on. Here you go. Right, now what I'm going to do is I programmed it that when the distance is too close, I mean 10 centimeters or less, then the buzzer goes off. There's a buzzer there. It's going to make a sound, and also it's going to turn the red light on to show there's a danger and there's an object too close to the sensor. So I'm moving my hand forward, as you see. Now you can see my hand on the camera as well. There you go, 9, 10, 8. See, so the buzzer goes off. Right, when I move my hand away, everything goes off. Nothing you can see. Here you go, distance, right? I move my hand away, it's blue. When it's gonna go about 20, it's gonna be green. Here you go, green, and then it's gonna be about 30, nothing's gonna happen. I'm gonna move back again, green. Now I'm gonna move further back. As you can see on the back of the screen, the distance is now 18, 19, right? Right, okay, move forward. There you go, 8, and the buzzer goes off. Now, in the next step, what I'm going to explain to you what hardware I use to build. Obviously, I use Python to program it, and I use this Raspberry Pi Pico, which is very cheap. You can get off the shelf for compared to other Raspberry Pi versions. And this is a sonic sensor, right? This is the one I'm pointing out right now, and I'm going to pick it up and show it to you, right? This one is a sonic sensor. I got 4 legs, right? The first one is VCC. VCC is where your power goes. So this goes into +5 voltage because it takes +5 voltage DC. So I'll show you later on the Raspberry Pi where you can pin it. The trigger is basically an ultrasound transmitter, right? That emits a high frequency sound of 40 kilohertz, and as travels through the air. And what it happens is that when it travels to the air, it finds an object and it bounces back to the module again. And when it comes back, there is another ultrasonic receiver which is called echo, as you can read on the pin, the third one. And that's the receiver that receives the reflected sound. And then when the sound goes in there and bounces it back, this is how it basically measures the distance. And there's a formula which I'll explain when I'm explaining the code, how basically this distance is measured. So this is how it works. Now, I think the important, and this is a buzzer which makes a sound, and this is LED light which turn blue, green and red. It's all RGB light. Now I think what I'm going to do is I'm going to take away the cable, and I'm going to explain you the cabling. Cabling is very, very important, because as a beginner, what you need to do is you need to use this. First thing first, you need to use, if you're using this small breadboard, you make sure you plug in the Raspberry Pi like this in the middle, giving it a little bit distance on both sides. So I left 2 pins on the left, 2 pins on the right, okay, and I placed it in the middle so that I can read clearly this pin 1 to pin 30, right? And on the same other side is also 1 to 30. So when I'm telling you where to place these pins, I'll be referring to these numbers, right? So you know where to put what, okay, and that becomes very easy for you. So let's start up with this one first. So if you look at it, I put at the last number, right? So if you look at it, that goes into the last pins, right? So that means this one is 30, right? Pin number 30. So VCC is pin number 30, trigger is pin number 29, echo is pin number 28, and ground is pin number 27, right? So if we look at the color, right? So VCC is red, then this is the first pin, and the second is orange, and then the green, and then the black. So these are the pins I placed it, and you can actually see it as well, because there are too many pins there. I also put some cables for the LED as well in front of it in the next row. So I'm using the row I for the sonic sensor, and the row G for the LED, and I place the LED in H. So I'll explain the LED later on. So let's first thing first. VCC is because it's a +5 voltage. So +5 voltage you can get from pin number 1, okay, on your Raspberry Pi Pico. So that's why the red one goes into this VCC. This VCC one goes into red. Then the trigger is gonna go into a GP pin, right? And also echo is gonna go into a GP pin, and the ground will go into a ground pin. So all these three I placed here, as you see here, these 1, 2, and 3. So these three, trigger, echo, and ground, I run it through this, and I put it here. So the orange one is obviously the trigger, right? Yeah, the orange one is trigger, and trigger goes into GP 0, which is on pin 1, and the echo goes, which is the green one, goes into GP 1, which is pin 2, right? And the ground will go into pin 3, because pin 3 is ground. You can pause my video and go back in there and learn how to pin this one. And then let me explain you about the RGB LED light, which has got 4 legs. So the first one is red, which is a red color, and then the tallest one is black. This one, see here, that's a ground. Then the next pin is for green color, and then the last pin is for the blue color. And I just put it like this behind these cables, and then I put these cables in front of it, okay? And you can do the same if you want to see here. I think it's a 26 row cable, and then 25, then 424, and then 23. And these cables run from here all the way and come here, right? So the black color goes into pin number 8. Why pin number 8? Let me show you a little bit here. Let me focus as well. The black color goes into pin number 8. Why? Because pin number 8 is ground, right, on the Raspberry Pi. You can check it on the back of it. And then the red color, which is this wire, this one, right? This one goes into pin number 9, and then the green one goes into pin number 10. This is the green one, and then the blue one next to it goes into pin number 11. So now the final thing is this buzzer here, right? This small buzzer. This buzzer, it's got 2 legs, right? So one is plus and one sign, and that's a bit slightly longer leg, right? That's the leg of output, and the next to it is the ground. So what I did here is I placed it at the end so it's easily explainable. So let me actually show you. So you see on the screen, I use a red color cable, which I put on 30, number 30 here, you see. And then I picked up a black color cable, which I put on 27. So if I put my long leg in 30 here on the back of it, maybe here, right, as you see, the other leg will automatically go into 27. So I placed this towards the end, so I pick up the long leg from 30. Yeah, let me focus so that you can read it. 30 and then 27. Okay, and then we run this cable, as you can see, on these 2 pins. So I put the red cable on pin 19, and I put the other cable, the black cable, which is ground, on pin 18. So this is the cabling explained, right? Now the next step is that I'm going to explain you the code. So let's start up from scratch. So in your Tony, you need to, in the main.py, you need to write this program Pico 0, right? Import RGB LED. So that's in capital RGB LED. So that's basically, you need to import RGB LED from Pico 0. So if you may get an error on this line if you haven't installed Pico 0 in your Tony. So I have a video there in my channel. It explains you how to install Pico 0 in your Tony. You need to follow those steps and install Pico 0 in Tony. The second, we need to import time, right? And then we need to import machine, right? These are the modules that we need. And from machine, I'll be using pin, right? And that's why I need to import pin as well. Now, first thing we need to do is we need to configure our HC-SR04 pins. So I showed you in the video that there is a trigger and there is an eco pin, and these trigger and eco pin I put on GP0. So that's why I'm going to pass on 0 here. And then because it's an out pin, because it sends out a sound that basically it's a sonic sound which goes to an object and bounce back. And when the sonic sound comes back, it is caught by echo sensor, which basically I attach to pin GP1, right? And because it receives it, that's why it's in, right? So this is something I need to do. And then the next thing I need to do is I need to define my RGB light, right? So I'm going to do this RGB LED, and I'm going to pass on the red color, which is basically 6, right? Green is 7. Why I'm saying 6, 7, and 8, right? The reason I'm saying 6, 7, and 8 is because this is where I placed my RGB light pins, right? So I put red, remember the red color pin or red color even cable, I put it on GP6, and then green color I put it on GP7, and the blue color I put it on GP8. There was another one, ground, which we don't need to mention here because we just need to put that pin there in the ground pin. Okay, now this is done. Next thing I need to do is I need to define my buzzer because it needs to make sound, right? So I need to define buzzer pin, which is for which I need to do the machine dot pin, right? I don't need to actually do the machine dot pin because I already imported this one. So even if I do this like this, it will not give me error. If I don't do this import pin, then I would need to put machine there, right? So I could do here is even this line of code is extra because I have imported pin from machine already. So I can remove this one, right? So here we go. I can leave it there. Either way, it's okay. This one pin is what was the pin was in actually? Pin was 14. Remember that buzzer? I put it on 14 towards the end. It was a black cable and a red cable, right? In the video I explained it to you earlier in this video. Okay, during the demo. So because it's a buzzer, so I send on GP14 a buzz, like a sound, which is out pin. I don't receive anything from the buzzer, I make the sound, so it's an out pin. I need to define that way. And now what we need to do is we need to define our function, which is get distance, right? Now I'm going to explain how this works. So I need to pass on 2 parameters to it, trigger and echo, right? So remember the trigger I'll pick up from this pin. It is a sound that basically send out, and then the echo is the sound that bounce back. So I put the trigger, pass the trigger and echo to it, and that's how I program my function. So let's finish this function off. First I need to send a 10. What I need to do is I need to send 10 US pulse to the trigger pin, right? So what I do is I say trigger dot low, I call this function, right? And then I give it a little sleep, right? So time dot sleep, okay, so go to sleep. Then I get the trigger high. We need to do this, right, to prepare the trigger for the function it needs to perform. So, and then I gave the trigger low again. Okay, now our trigger is sending these pulses, right, every 10 seconds. So it basically goes into it's a microsecond, sorry, so every 10 microsecond it's sending out these pulses. Trigger go higher and then low, then again higher and low, and that's how it's sort of like to send these sounds out. Because we need to send these sonic sounds out, and I explained in the video why we need to do that, because that's the basic functionality of this trigger sensor, right? So it sends the sounds out and then you see the sound back. Now next one, what we need to do is now we need to measure the duration of the incoming pulse. So we send the pulse out every 10 microsecond, right, using this code here. So first thing we need to do is that we need to send the 10 microsecond pulse to the trigger pin, right? So for that one we will do the trigger.low, right, and then we to put a timer there, make it sleep for 2 microseconds, right? Okay, 2 microseconds, and then we trigger high, that's a pulse we send out high, and then we make it sleep for 10 microseconds, right? Okay, and then we bring the trigger low again. This thing is basically creating the sound waves that is being sent out to trigger every it makes it low, goes back to sleep for 2 microseconds, and then makes it high, and then goes back to sleep for 10 microseconds, and then make it low, and then make it high. So this way it fluctuates and sends out the trigger sound. So when it basically goes out, the next thing we need to do is it basically gonna come back to the echo pin, and that's where we need to measure the distance, for which we're going to write a small while. Okay, write a small while echo dot value, because we need to now cache the value from echo, right? So while echo value is equal to 0, right, what we need to do is we need to turn the signal off timing. So that means that when the echo value is 0, signal is off. So we just need to get the takes in microseconds, that how long what is the time in microsecond when the signal was off, right? And that's when it is not receiving any data. And then we write another one, a while function here. Okay, and this one we say echo dot value while echo, and this loop is going to keep running as long as value of echo is equal to 1, which means it's receiving the data. So it's gonna just that's when the signal is on. So it's gonna basically get the signal on and get the time in microseconds for when the signal was on. So we got now when the signal was off and when the signal was on. So that's the time we got. And if we basically do the signal off time, on time minus signal off time, we'll get the actual duration for the past time. So we need that past time. So we say signal on minus signal off. So that will give us the duration that has been passed between that time when the signal was on and signal was off. And why we need that duration? We need that duration to measure our distance, right? And for that one, we will do is we say time passed, okay, multiplied by 0.0343. Now you must be wondering what this 0.0343 is. So 0.0343 is basically a speed of sound, right? And that is basically 0.0343 is centimeter per microsecond, and that's the centimeter per microsecond is the speed sound. So we need to multiply the time passed with the speed of sound. That is a fixed constant variable. Okay, the way they calculate it is that it is basically 343 meter divided by the divided by the 300 basically it's a 343 meter per second, actually 343 meter per second, which is equal to 0.043 centimeter per microsecond. That's the speed of the sound. So we need that, right? And why we need that is something I just explained to you, right? So let's go to the next one now. So here we need to divide it by 2. That's our formula, right? So time passed divided multiplied by 0.0343, which is speed of sorry, yeah. So this is how we calculate our distance. So next is, once we calculated our distance, we return it, right? Okay, so now we have returned the distance. Next thing we need to do is we need to write another while loop, right? So this will be here while, right? And while true. This is a indefinite loop. True, as long as true, right? Oh, here you go. True. While true, what we do, we get the distance. We say distance is equal to we call the get distance function. Now you know how you can use functions when you're actually doing the programming. We can just pass on trigger and equal to it, right? And this will bring back the distance to us. So it gives us the distance, and then what we're going to do is, remember that when we ran that program, it was printing here the distance. So that's why you need to put a print command there. Okay, and you say distance, okay, equal to, and then what you can do is you can put here comma distance comma, and you put the centimeter next to it. So you could do this. So this will print it as it is on the screen. And next thing, we need to put the logic now for our buzzer and colors, right? So that's very simple. You just do distance, okay, is greater. Remember that when we said when our distance between our hand and the actual sonic sensor is greater than 20, and distance is less than or equal to 30. It's between 30 and 20. What you do? You set the RGB dot color to red. Now that was 255 is actually green. This one is green. So we set the color to green, and the buzzer should remain off, isn't it? So for buzzer, to keep the buzzer off, we need to do is we need to set the buzzer value with where I say buzzer dot buzzer underscore pin. That's a variable, right? Value, and we're going to pass 0 to it, so it means it remains off, right? And the second is alif. What was that second alif? Alif. It's not alif. Alif. And the distance is greater than, say, 10, and distance is less than equal to 20, right? If it's between 10 and 20, what you should do, the RGB color should be set to, this is the parameter you pass for blue light, 255. Okay, that's a blue light, and the buzzer remain off, right? Value 0, right? That's the buzzer code. Now the last one is that if the distance is, and that's going to be alif, another alif, okay, distance is greater than 0 and distance is less than equal to 20, right? Not 10. All right, yeah, 10. So if it's too close, what did I do in the program? I turned the red light on. So what is the code for red light? The code for red light is 20. Okay, so basically red light is 255, right? 255 0, and 0 and 0. This is your red light on. Now you turn the red light on, and also you need to, this time you're not going to pass on 0 to the buzzer. You're going to pass on 1, which means turn it on, right? The only time it will turn it on when the distance is between 0 and 10, right? And then you can do is L part, right? Else if that's not the case, which means the value is not between 20 and 30, not between 10 and 20, not between 0 and 10, you must set the RGB. This is going to give me an error later on. It's RGB, guys. GB. This is also RGB, right? This is not R. Make sure you have the same variable. So I sometimes make mistakes, which will give an error later on. So I don't want to do that. So what I'm going to do is I'm going to set the value to 0, 0, 0, which means no color, right? And then also I'm going to put the buzzer off, right? In dot value. So we need to put the buzzer off as well. We need to put the value 0, so the buzzer is not making any sound, right? So this is how basically we do this. Now, and after, while this loop is running, you gotta give a little bit under the, you gotta make it sleep as well for say 5 seconds, so that it doesn't burn out your pins. And so this is how you program it, and let's hope when we run this gives us the distance. And I'm gonna run this one. All right. Oh, I got an error. It's always an error, isn't it? So that's not a problem. We can fix the error one by one. What is the error? It says invalid syntax on line 30. So it's always either you have misspelled anything, or let's go to line 30 and actually see what is the error. RGB color. Oh, all right. Okay. So I need to put here equal sign, guys. It's always do this. It's not like this, it's equal sign. Alright, always make this mistake. So this is equal sign. This is also equal sign. Right? This is also equal sign. And now we run it, and let's see what else we get. Invalid syntax on line 30 again. What? Same problem. Line 30 is here. RGB.color is equal to that's not, oh, here you go. That's why I need to put here the colon, and here colon as well. There's an error on the if condition. Okay, now we got a RGG. This is a mistype, right? It's not RGG LLBD. This is RGB LED. So it's on top, line number 7. So this one is RGB LED, not RGG. So one by one we're gonna get rid of all the errors. And now what else are we gonna? Tick.s, time.ticks.s. It's not tick.s, it ticks.s. Why is it tick.s? It ticks. Where is that? 24 and 20. So here, this is ticks, guys, on line 19, and this is ticks. So yeah, you gotta get rid of it. Troubleshooting is always amazing. Then we need to run this one. Right, okay. So you see here, it's running fine, right? It's running and it's giving you all what you need, right? So I put this code there on the LMS as well, so you can copy paste the code. You don't have to write the whole code. Enjoy your programming. Thank you.